Hi, I'm Kim Wei-Chek. I'm going to present this paper called DiffRoll, Diffusion-Based Generative Music Transcription with Unsupervised Pre-training Capability. This work is a collaboration between Singapore University of Technology and Design, Agency for Science, Technology and Research, and Sony. Before we start, I would like to provide a high-level summary of what DiffRoll is. DiffRoll is a generative model. Due to its generative nature, DiffRoll is capable of both AMT and music generation. It can also be trained on unpaired data, making it possible for unsupervised learning. The novelty of this work is that we tackle a discriminative task using a generative model. The AMT accuracy can be improved using unsupervised pre-training. And finally, it has the ability to impinge the missing audio transcription segments with the music generated by the model. Now, let's talk about what is automatic music transcription, also known as AMT. It is the process of transforming audio data into symbolic representations such as music scores, which is analogous to automatic speech recognition, also known as ASR. Working in time domain is extremely difficult. Therefore, we define our problem as converting spectrograms into piano rolls. This is how people model AMT conventionally. They have a model to convert the spectrograms into piano rolls deterministically. In this work, we model AMT differently. We consider it as a generative task instead of a discriminative task by using Gaussian noise as the input to the model instead of the spectrograms. We want our model to generate piano rolls based on the input. To control the piano rolls to be generated, we use spectrograms as the condition. In other words, we model AMT as a conditional generation task. The model architecture of DiffRoll follows DiffWave, with some minor modifications. For example, the input is of the shape of piano rolls instead of waveforms. Also, the input channel for the first convolutional layer is 88, corresponding to the number of notes in the piano rolls instead of 1, as in the original DiffWave. After understanding the model architecture, we will talk about how to obtain the Gaussian noise during training. To obtain the Gaussian noise as the model input, we use this forward process. We start with x0, which is the piano rolls in the binary format, and then we use this equation to obtain the next time step, x1. We continue this process until we obtain xt. Each diffusion step introduces noise to the input. When t equals to capital T, it becomes Gaussian noise. To make the training more efficient, we can obtain any xt from x0 using this equation. The alpha here is the scheduling coefficient which controls how much noise to be added during each forward step. In short, DiffRoll is a model that generates posterograms from the Gaussian noise using spectrograms as the condition. The L2 loss between the posterograms and the ground truth piano rolls is the training objective of our DiffRoll. After training, we have this sampling scheme to obtain the transcription results and use it for model evaluation. We sample x0 from a pure Gaussian using the following reverse process. First, we obtain x0 hat based on the input xt and the condition, which is the spectrograms. Next, we estimate the noise epsilon at diffusion time step t based on x0 hat. After that, we estimate xt-1 based on epsilon t. We continue this process until x0 is arrived. In the context of DiffRoll, the sampling scheme is like this. We use the model output as x0 hat. Then we use it to obtain epsilon t, and epsilon t is used to estimate xt-1. After that, xt-1 is used as the new model input, and we continue the same process to obtain xt-2 until x0 is arrived. This animation demonstrates the sampling process. Now, we want to compare the transcription accuracy between discriminative AMT and generative AMT. We use MAPS dataset in our experiments. Following the existing conventions, we removed overlapping pieces between the training set and the test set, resulting in 139 training samples and 60 test samples. During training, 20-second segments of audio are randomly extracted and are converted into MELS spectrograms. We use diffusion time step t equal to 200. All of the models are trained for 10,000 epochs. We use the same model architecture for both discriminative AMT and generative AMT. But in discriminative AMT, the diffusion time step is removed and the spectrogram is used as the input instead of the condition. Here's the result. Generative AMT has a higher transcription accuracy than the discriminative AMT. In the following section, we will explore the generative properties of DiffRoll. If we trained our DiffRoll using the spectrogram condition C, it cannot generate new piano rolls. But without the spectrogram condition, DiffRoll cannot learn to transcribe spectrograms. Is it possible to train DiffRoll in a way that it can transcribe and generate music? The answer is yes. We need to use classifier-free guidance. Instead of using the spectrograms directly as the condition, we add a dropout layer to mask out some spectrograms in a batch to be all -1. This allows our model to be trained conditionally and unconditionally at the same time. Other than this, the model training is basically the same, but the sampling is a little bit different. Originally, the model output is already the X0 hat. With classifier-free guidance, we need to combine the conditional and unconditional prediction to obtain the X0 hat. After this, the sampling is basically the same. Experimental results show that classifier-free guidance can further improve the transcription accuracy. The unconditional part of DiffRoll implies that it can be trained using unpaired piano rolls. This can be used to pre-train DiffRoll in an unsupervised manner. In the following experiments, we pre-train DiffRoll using only the piano rolls in the Maestro dataset, and then we continue training DiffRoll using MAPS dataset as usual. Experimental results indicate that unsupervised pre-training is useful in improving the transcription accuracy. However, the existing semi-supervised AMT model, we call VAT, is still slightly better than DiffRoll. We will further improve DiffRoll as our future work. Let's listen to the transcription demo. Next, the demo for in-painting. Finally, the demo for music generation. That's the end of my presentation. If you're interested, feel free to read our paper and have a look at our demo page. See you in the conference.